Hi guys, there was a question from one of the homework assignment from section 5.4, problem number 199. So basically we have an infinite series, which is n equals to 1 to infinity, n factorial over n plus 2 factorial. So they ask us specifically to use comparison tests to decide if this series converges or diverges, okay? So, and you got to be careful because I'm sure you have already been noticing that different variety of tests you can perform. So when the instruction says use a certain test, especially on the quiz or exam, you have to make sure you use that particular test. Even though you may be able to use other tests to show the same thing, but you have to always follow the instructions. So we're going to use comparison tests. Now by the name, what that means is you have to find another series for which you know either it converge or diverge, and then you'll be able to compare your series to that series. Now, I mentioned this before in the context of our last chapter, that if you want to compare, so if you want to prove convergence, you have to make sure you show that your series is less than something that converge. If you want to show divergence, you have to show your series is greater than something that diverge. Okay, make sure you get that basically direction straight, because some people get confused on how to compare. So first thing first, of course, all of you know what factorial means, of course. So n factorial basically means that is n times n minus 1 times all the way to 1, right? So also if you look here, we have n plus 2 factorial, which basically means that we have n plus 2 times n plus 1, and of course you keep subtracting until you get to 1. So just to remind you, for example, if you have 5 factorial, of course that n could be any number. If it's 5, you start from the same number, and then you multiply, keep subtracting 1, so that's 4, then keep subtracting 3, 2 until you get to 1, right? So that's what we call factorial. So if you make that observation, then you notice that n plus 2 factorial really has n factorial in it, because if you start from n plus 2, let me just rewrite this. So this is really the same thing as n factorial over, now n plus 2 factorial would be, of course, again, starting from the number itself, and then you subtract 1 from this number, which becomes n plus 1, but then the next one would be what? N, and then times n minus 1, which is exactly the same thing as what we have upstairs, which is n factorial. And really that's the main idea, main observation you need to make. Because once you make that observation, then I think everything should fall in place. So now you cancel the n factorials. So at the end of the day, what you have basically is a series, just simply 1 over. Now, you can do the full method here. If you multiply these, I believe you get n squared plus 3n plus 2. I'm going to just pause there for a second. So now this is the same thing. It's the same series. We just basically took the factor of n factorial from top upstairs and downstairs, okay? So now, once you see that, I'm sure now you hopefully have some idea what you're going to compare it to. So remember, we have n squared down here plus something positive. So I'm going to go ahead and go up here. So the first observation I'm going to make here is that what we have in the bottom, which is n squared plus 3n plus 2, is actually always going to be greater than n squared. And that obviously is obvious because you're adding a positive number, because remember, n are positive integers. You're adding a positive number to the same quantity, so it becomes bigger. But remember, we have 1 over. So as you reciprocate, and that's how we're going to see our correct direction here. So as you reciprocate, 1 over that becomes, of course, less than 1 over n squared. Because remember, if a is less than b, then 1 over a is always going to be, if a is greater than b, then 1 over a is less than. And of course, now it's pretty much over, because as you know, by the way, if you go to your textbook and look on page 477, on page 477, basically, on the very bottom of page 477, it talks about the so-called p series. And if you have 1 over n to any power p, as long as p is strictly greater than 1, this series converge. These are called p series. And on the bottom of page 477, they give you the convergence and divergence. When do they converge, for what p values? So if p is larger than 1, like in this case p is 2, then these series converge, okay? And that's pretty much it, because now you found a series, of course, that, in other words, if you put a sum here, then obviously that means for every n, that's also true. But then this series converges. So I'm just going to say since the series 1 over n squared, which by the way is one of those so-called p-series, converges by comparison test R series also converge. So I'm just going to say n factorial over n plus 2 factorial converges. Let me make sure you can see that. Okay, so let me just repeat basically. So what we did, we were able to show that R series is less than a series that converge. And of course, those are called the P series. As long as P is larger than 1, they will always converge. And so by comparison test, of course, because R series is less than something that converges, R series also converges. Now, by the way, if you wanted to prove divergence, you have to make sure that your series is greater than a series and diverge. Okay, so make sure you always get that order straight. Okay, hopefully that helps.